Hello and welcome back to our second video on exponential functions. Today I'd like to take a look at another category of solving equations that involved a little bit of a different approach than the one we saw in the previous video. So I believe we were down to example 3. These ones, like I said, are perhaps a little more involved, so we're going to give them 3 stars. And we will try to solve the following equation, which I have here. What do we have here? Solve 2 to the x plus 2 to the minus x is equal to 17 over 4. All right, so here we have 2 to the x and 2 to the minus x. This type of situation calls for, when we have like different things like this, it calls for a substitution. We're going to let that 2 to the x expression, we're going to replace it by another letter. That's what we call a substitution in mathematics. So you replace one entity by another, hence hopefully simplifying the original equation. So 2 to the x plus 2 to the minus x equals 17 over 4 becomes, if I replace 2 to the x by t, here's something I'd like to do before that. I'd like to say 2 to the x plus, what's 2 to the minus x? Another way to write this is 1 over 2 to the x, yes? Okay. Which becomes in turn what? T, because 2 to the x is replaced with t plus 1 over t equals to 17 over 4. Kind of a rational equation here because I have a ratio, so I'll take a common denominator, t, on the left side. And I'll cross multiply, so t squared plus 1 is 17 over 4. I'll do another cross multiplication, so 4 times t squared plus 1 is equal to 17t. Yep. I'm going to bring the 4 inside and bring the 17t to the other side, and I'm going to get the following quadratic equation. 4t squared minus 17t plus 4 equals to 0. So I'm pretty sure I can factor this, right? How can we factor this? This would be 4t and t. I'll have a 4 here and a 1 there, and a minus, and a minus, and that will work. So what I did is product sum in an accelerated way. So my two answers for t, not for x, for t, will be, all right, 4t minus 1 equals to 0, or t minus 4 is equal to 0. Solve this, that's 1/4. Solve this, that's 4. Now remember that t originally is 2 to the x. So that's 2 to the x is equal to 1/4, which is 1 over 2 to the 2. Or 2 to the x is equal to 2 to the 2. So what I have here is 2 to the x equals, let's bring this guy up. 2 to the 2 is downstairs, bring it up, it becomes 2 to the minus 2. Notice the same base, we solved that in the previous video. Same base means the exponents are the same. Here's my first answer. My second answer is even more straightforward. 2 and 2 are the same base, x equals to 2. And these are my answers. 2 and minus 2 will both satisfy the original equation that is here. Good. All right, so substitution sometimes is useful when the equation gets a little more complicated. So let's see if we can do another one. All right. All right. So, second one of the day. Call it example 4. Like this one, a little more challenging yet. 3.5 stars. Solve 10 to the x minus 10 to the minus x over 10 to the x plus 10 to the minus x equal to 0. Okay. Again, a similar situation as before, where we had 2 to the x and 2 to the minus x. Here I have 10 to the x and 10 to the minus x. So a substitution is in order. I'm going to let t equal to what? 10 to the x. Yes. Okay, so this becomes 10 to the x minus 10 to the minus x over 10 to the x plus 10 to the minus x equals 0. This becomes, I'm going to deal with my negative exponents like I did before. That's 10 to the x minus 1 over 10 to the x. Same thing downstairs with a plus. And then I am going to change my 10 to the x to a t. So that's t minus 1 over t plus 1 over t. All this equals to 0. That is a complex fraction that requires a little bit of simplifying. So common denominator, I'm going to get t squared minus 1 over t divided by t squared plus 1 over t equals to 0. That's my new equation. Complex fraction, I got to flip this around. So t squared minus 1 over t. Divide by that means multiplied by the reciprocal. My t's will cancel. I will now have t squared minus 1 over t squared plus 1 equal to 0. 0 is the same as 0 over 1. So cross multiplying, 0 times t squared plus 1 is gone. And 1 times t squared minus 1 is actually equal to the other side, 0. Difference of squares, t minus 1, t plus 1. So it seems like we have two answers, like t equals to 1 or t is equal to minus 1. But we actually remember one thing, t was 10 to the x. So either 10 to the x is 1 or 10 to the x is minus 1. Well, 10 to the x equals 1. 1 is the same thing as 10 to the 0. Oh, that's nice because now we have the same base, 10 and 10. So it follows that x is 0. As for the other side, change sides again. As for the other side, that's going to be pretty hard to write minus 1 to 10 to the something, right? Fact is here, there is no solution to this guy. Here's why. What's the graph of y equals 10 to the x? Remember that from the previous video? 10 to the x is like 2 to the x. It actually does something like this. When is this graph in contact with the x-axis? Never. It simply never touches the x-axis, which means that y is never equal to 0. So basically, all the range of this function is all positive. It is never a negative value. See here, my graph is above the x-axis, so it's always positive. 10 to the x is always greater than 0, never negative. So there is no solution to 10 to the x equals to minus 1. So my final answer is just 0, which is the answer I got for t is equal to 1 right over here. Okay, good. Challenging little problem. Let's do another one. Let's do another one. All right. So this would already be example 5. So example 5, still 3.5 stars. Or no? Well, you'll be the judge. Find all the zeros. So here I'm wording the question in a slightly different way, but you'll see that it is quite the same thing as what we've done before. Find all the zeros of, what's the function that I have here? For f of x equal to x e to the minus x minus 2e to the minus x. Okay, so finding the zeros mean what? Finding the zeros, what's a zero? It's a value when y is equal to what? 0, yes? So when y is equal to 0, so let me write this down. Zeros happen when y is equal to 0. Now y has another name. Y is the same thing as f of x. So I'm going to replace f of x by 0. So we need to solve 0, which is my f of x, which is my y, equal x e to the minus x minus 2e to the minus x. Good. How shall we solve this? Perhaps we can think of factoring something out of this. What about what's common between those two guys? I think e to the minus x is common to these two guys. And if I factor it out, I will get x minus 2. So that's a similar yet different type of factoring that we've seen before. But the active principle is the same. Either e to the minus x is 0 or x minus 2 is 0. That one is easy to solve. Let's take care of that right now. X is equal to 2. What about this? How can I solve e to the minus x is equal to 0? Well, if you remember the graph of e to the minus x is equal to y, you're going to get something, maybe a different color, e to the minus x goes like this. Now, if I want this to be equal to 0, I would like the red curve, which is e to the minus x, to actually touch the x-axis. That's why the y value is 0. Does it ever touch the y-axis? Is this ever equal to 0? No. So y is never equal to 0. So e to the minus x is never equal to 0. This again has no solution, leaving me as the only solution to this problem the value x is equal to 2. And that's the only answer to this question. All right, that was example 5. Good. So finding the zeros is the same thing as really solving, because we replace f of x, which is y, by 0. Okay. So perhaps enough on this topic. And let's take a look now at something a little bit different, which I'm going to call simplifying exponential expressions. Exponential expressions. Okay, what do I mean by this? Well, there is no theory on this, only example. So let's restart our list of example at example 1. I do believe that the manipulation here requires 3 stars. So simplify completely. Simplify completely. The following expression, e to the x plus e to the minus x over 2, close bracket, minus e to the x minus e to the minus x over 2. All right, so believe there's a square here, and I believe there's a square there as well that I forgot. So this is a fairly intricate expression that certainly can use our TLC, tender loving care, to simplify. How shall we do this? Well, I got a square, so I'm going to say that this is equal to e to the x plus e to the minus x over 2. Square means times itself, times e to the x plus e to the minus x over 2. Middle sign, minus. Then I'm going to do the same thing here. This is a square. E to the x minus e to the minus x over 2 times itself. All right, we got our work cut out for us here. How shall we attempt to do this? Well, fraction times fraction, so the denominators should multiply each other. 2 times 2 should be 4. And now we FOIL, and now we FOIL. E to the x times e to the x. Same base, we add the exponents. E to the 2x. Je répète, e to the x times e to the x, same base. We add the exponents. X plus x is 2x. E to the x times e to the minus x. Same base e, we add the exponent. X plus minus x, 0. Good. Now, again, e to the minus x times e to the x, same base, we add the exponents. Minus x plus x, 0. And finally, what do we have here? We have e to the minus x times e to the minus x. Same base. We add the exponents. Minus x plus minus x is e to the minus 2x. Right? E to the minus x, e to the minus x. We add minus x and minus x, we get minus 2x. And that is over 4. Lovely. Minus. All right, big bracket. Also over 2 times 2, 4. Let us FOIL. E to the x times e to the x. Same base. We add the x's, 2x. E to the x times minus e to the minus x. So a plus times a minus, that's going to give me a minus, and that's going to be e to the what? X plus minus x, 0 again. Minus e to the x times e to the x. Same base, we add the powers, minus x plus x, 0, but with a minus. Like this. Et finalement, this time is a minus times a minus, so it's going to turn out to be a plus. And I'm going to add my exponents, minus x plus minus x minus 2x. Wow, that is a fairly involved expression. Good. So what do we got? Here? E to the 2x plus, what's e to the 0? 1. Another e to the 0. 1. So that's 2. Plus e to the minus 2x all over 4. Okay, I'm going to change my signs here. Minus this guy, minus e to the 2x, all over 4, of course. And then that's minus 1, no? Because e to the 0 is 1. So minus 1 is what? Minus 2 with a minus is a plus 2. So I'm going to put a plus here and a minus there. And finally, minus e to the minus 2x. Minus e to the minus 2x. Wow. All right. What's all this? What is all this? Well, it is all over 4. This going to cancel with this. This going to cancel with that. What am I left here? 2 and 2. Woo! That's 4 over 4. Wow. Look at that. That is equal to 1. So a lot of algebra to actually come up with a very puny little answer. So again, what did I do here? I put everything under the common denominator, and then I canceled the ones that were opposite in sign. So e to the 2x minus e to the minus of 2x. Those two are the same but minus. E to the minus 2x, e to the minus 2x. One is a plus, one is a minus. And finally, 2 plus 2 is just what's left. 4 over 4 is 1. Good. Wow. Maybe that deserves another half star. What do you say? 3.5 for this guy. Yes? Okay. Let's see if we can do one last one for today of the same nature. They look intimidating, but really, it's the same rules that we have applied again and again and again with the rules of exponents and the rules of FOIL. That's what it is. All right, so this would be example 2. You know what? Let's give it another 3.5 stars, this guy. So, last example, simplify. Simplify. Simplify what? Oh, that looks like the one before, but it's not exactly the same. Check it out. E to the x plus e to the minus x over 2. Square that thing. Plus e to the x minus e to the minus x. Square. Also over 2. Did I do this right? It looks okay. All right. All right. So we shall simplify this by starting by saying a square is times itself. So I'm going to rewrite this dude. E to the x plus e to the minus x over 2 times itself. Over 2. So times itself. Middle sign is a plus, and then that's also a square. So this guy times itself. E to the x minus e to the minus x over 2 times itself. All right. Again, the good old technique of FOIL to the rescue. We've done this several times now. I guess we're good with it. E to the x times e to the x. Same base, add the exponents. X plus x is what? 2x. So e to the 2x. Now, e to the x times e to the minus x. Same base e, add the powers. X plus minus x, 0. E to the minus x times e to the x. Same base, add the powers, minus x plus x. Here's another e to the 0. And finally, e to the minus x. Try with this, my left hand. E to the minus x times e to the minus x. Same base, add the powers, minus x plus minus x is minus 2x. E to the minus 2x. Tutta la familia over product 2 and 2 is 4. Plus, I don't really need a bracket here because there's a plus in front of the whole thing. So again, 2 times 2, the bottom is 4, and we FOIL the numerator. Vamos. E to the x times e to the x. That's the 4th time we see that. That's e to the x plus x. Now watch your signs here. E to the x times minus e to the minus x. So that's going to be a minus e to the, let's add the powers, x plus minus x, 0. Now this, minus e to the minus x times e to the x. So a minus and a plus, it's going to be a minus. And we add the exponents, minus x plus x, that's a 0 as well. Yep. Finalement, the last term, that's a minus times a minus, so we get a plus. E to the, let's add our powers, minus x plus minus x, it's minus 2x. And the bulk of the work is now done. Let's collect our like terms. E to the 2x, what's e to the 0 again? It's 1, plus 1, plus 1, plus e to the minus 2x. I'm going to take a big common denominator of 4 plus e to the 2x minus 1 plus e to the minus 2x. All right, cancellations here. Plus 1, minus 1, minus 1. Like terms, e to the 2x plus e to the 2x. So that would be 2 e to the 2x. E to the minus 2x plus e to the minus 2x is 2 times e to the minus 2x all over 4. I can take out a 2 from here and get e to the 2x plus e to the minus 2x over 4. 2 and the 4 will cancel, give me a 2 downstairs. This is e to the x plus e to the minus 2x, all this time over 2. And since I am not in the habit of leaving any answers with a negative exponent, I will make this extra effort to get rid of the minus exponent here. So I need to create a little bit of space. Let's go over here. So e to the 2x plus, negative exponent. We know what this means, huh? Anything with a negative exponent is 1 over. So 1 over e to the 2x all over 2, which means that I can say e to the, okay, so common denominator for this guy. Common denominator for the numerator shall be e to the 2x, and that's e to the 2x times e to the 2x plus 1, and this whole thing is divided by 2. And this whole thing is divided by 2. So that means what? Again, same base, add the exponents. E to the 4x plus 1 over e to the 2x. And division by 2 means multiplication by 1/2, which gives us our final answer right here. E to the 4x plus 1 over 2e to the 2x. And that is that. And this is this. And we are done with this problem. Good. So we'll practice some more in class. And the next time we meet, we're going to take a look at the interesting part, if you want, of exponential functions, which are the applications that we're going to look at. Some applications to social science and some applications to economics as well. In the meantime, be well and stay safe. Goodbye.